The night sky stretches above us, an endless canvas of stars whispering secrets we've only begun to unravel. Each pinprick of light holds the possibility of worlds unknown, places where life might flicker in the vast darkness. For years, we've dreamed of finding another Earth, a planet cradling oceans, forests, and skies painted with clouds. But what if the answer isn't a planet at all? What if the cradle of life lies not on a solitary world orbiting a star, but on a moon tethered to a giant planet dancing in the cosmic waltz of a distant system? The idea of habitable moons, worlds like our own, orbiting gas giants in the sweet spot of a star's embrace, ignites a spark of wonder. Could these moons, hidden in the shadows of their massive hosts, be the key to finding life beyond our solar system? The thought alone pulls us into a story of hope, mystery, and the delicate balance of cosmic forces. Let's journey to a distant star, 44 light-years away, to a gas giant called Majraditi, and explore the tantalizing chances of habitable moons. Imagine standing on the surface of a moon orbiting Majraditi, a behemoth 10 times the mass of Jupiter, its swirling storms filling the sky like a living painting. The planet looms so large it feels like it could swallow the horizon whole, its bands of amber and crimson casting a surreal glow across the alien landscape. You're not on a planet orbiting a star, but a moon orbiting a planet, yet the ground beneath your feet feels solid, familiar. There's air to breathe, a gentle breeze carrying the scent of something strange yet alive. The star, a distant sun-like beacon, bathes the scene in golden light, just warm enough to sustain liquid water. This isn't science fiction. It's a possibility, one rooted in the latest discoveries about exomoons, those elusive worlds that might hold the key to life in the universe. But the path to such a place is fraught with challenges, a cosmic gauntlet of radiation, tidal forces, and the sheer improbability of getting everything just right. The story of habitable moons is one of delicate hope, where the odds are steep but the rewards are breathtaking. Majraditi, floating 44 light-years from Earth, is a gas giant that sits in its star's habitable zone, that Goldilocks region where conditions might allow liquid water to pool on a world's surface. It's not the planet itself we're interested in. Gas giants like Majraditi, with their crushing atmospheres and lack of solid ground, can't support life as we know it. But their moons? That's where the magic might happen. Picture a moon the size of Earth, carved from the same cosmic material that formed its parent planet, orbiting in a delicate balance. These moons could be rocky, like our own world, with the potential for oceans, atmospheres, and even ecosystems. The idea is intoxicating. A single gas giant could host not one, but multiple moons, each a potential haven for life. A single star system could offer a handful of chances for habitability, multiplying the odds in our favor. But before we let our imagination soar too far, we need to ground ourselves in the realities of what makes a moon habitable and what makes it a hostile wasteland. The first hurdle is size. A moon needs to be big enough to hold onto an atmosphere, to cradle liquid water, to sustain the geological churn that keeps a world alive. In our own solar system, moons like Europa and Ganymede hint at what's possible, but they're icy worlds with hidden oceans beneath frozen shells. We're chasing something different, a moon that mirrors Earth, with air you could breathe and landscapes you could walk without a spacesuit. Studies suggest that planets like Majraditi, massive enough to border on becoming brown dwarfs, could host moons as large as Mars or even Earth. The math is promising. Jupiter's moon system, for example, has a combined mass greater than Mercury, split across its 4 largest moons. Scale that up to a planet 10 times Jupiter's mass, and you could have a moon with the heft of Earth itself, or several Mars-sized worlds. The bigger the planet, the bigger its moons can be, and the closer that planet is to its star's habitable zone, the better the odds those moons could support life. But size is only part of the equation. A moon orbiting a gas giant faces dangers that planets like Earth never encounter. Imagine the radiation belts of a planet like Majraditi, a magnetic field so powerful it could strip a moon's atmosphere faster than it can form. Jupiter's moon Io is a stark warning. It's the most volcanically active body in our solar system. spewing molten rock in a desperate attempt to build an atmosphere, only to have it torn away by Jupiter's relentless radiation. Step onto Io's surface, and even with shielding, you'd be dead in hours, bathed in a lethal glow. A habitable moon would need to orbit far enough from its planet to escape this cosmic assault, yet close enough to benefit from the planet's warmth and tidal forces. These forces, caused by the gravitational tug-of-war between moon and planet, can heat a moon from within, potentially keeping it warm even if it's far from the star's light. It's a delicate balance, like a tightrope walker navigating a storm. Tidal heating is both a blessing and a curse. It could warm a moon to Earth-like temperatures, even if it orbits beyond the habitable zone, creating pockets of potential life in places we'd never expect. But too much tidal heating, and the moon becomes a volcanic hellscape, like Io, or a barren rock too hot to sustain water. Then there's the issue of tidal locking, where one side of the moon always faces its planet, much like our moon always shows the same face to Earth. This could create wild climate extremes, one side baking under constant planetary glow, the other frozen in eternal night. The interplay of these forces, radiation, tidal heating, orbital distance, creates a narrow window where habitability is possible. It's like threading a needle in a hurricane, but the possibility, however slim, keeps us searching. The question of how common these moons might be hinges on how they form. Around a gas giant like Mudridi, moons coalesce from a disk of gas and dust, much like planets form around a star. The closer the planet is to its star, the denser this disk tends to be, leading to fewer but larger moons. A study modeling 10 Jupiter-mass planets around Sun-like stars found something remarkable. At 1 astronomical unit, the distance from Earth to the Sun, squarely in the habitable zone, the average moon size is about 46% of Earth's mass. That's big enough to hold an atmosphere, to cradle oceans, to maybe, just maybe, support life. Move that planet further out, to 2 or 3 astronomical units, and the moons get smaller and more numerous, their sizes dropping to a third or even a tenth of Earth's mass. The further from the star, the harder it is for these moons to stay warm without intense tidal heating. Yet even at 5 astronomical units, Jupiter's distance from the Sun, there's a slim chance for a moon to be warmed just enough by tidal forces to mimic Earth's climate. It's a long shot, but the universe is vast, and long shots have a way of paying off. The emotional weight of this search hits hard when you think about what it means. Finding a habitable moon wouldn't just be a scientific triumph. It would rewrite our understanding of where life can exist. It's not just about finding another Earth. It's about discovering that life might thrive in places we've barely considered, orbiting giants in the outer reaches of a star's light. The universe could be teeming with these hidden worlds, each one a tiny beacon of possibility. But the challenges are daunting. A moon needs water, a stable atmosphere, a magnetic field to shield it from cosmic rays, and 1,000 other things to go right. The study suggests that over half the moons around a 10 Jupiter-mass planet at 1 astronomical unit are too hot, scorched by tidal forces. Move further out, and most become too cold, starved of starlight. The window for habitability is razor thin, yet it exists. That sliver of hope, that faint chance, is what drives us to keep looking. As we stand on the edge of this cosmic frontier, the story of habitable moons feels like a call to adventure. It's not just about the science, it's about the human need to explore, to dream, to find our place in the vastness. Mudridi and its potential moons are just one chapter in this saga, a glimpse of what might be waiting. The universe doesn't owe us answers, but it teases us with possibilities, daring us to chase them. In the next part, we'll dive deeper into the specific planets we found that might host these moons and the unique challenges they face in cradling life. For now, let the idea settle in your heart. Somewhere out there, a moon might be orbiting a giant, its surface kissed by alien seas, whispering that we're not alone. The universe is a storyteller, weaving tales of worlds that spark our deepest curiosities. We've ventured to the edge of possibility, imagining moons orbiting gas giants like Mudridi, their surfaces alive with the potential for oceans, air, and life. These aren't just distant dreams. They're grounded in the cosmic mechanics of how moons form and survive. But now let's step closer to the stars we've actually found. Planets that might cradle these habitable moons and face the heart-pounding challenges that could make or break their chances. The search for life is a tightrope walk between hope and harsh reality, and every step forward reveals a universe both generous and unforgiving. Picture a star system 44 light-years away, where Majra reigns, a gas giant 10 times Jupiter's mass, sitting perfectly in its star's habitable zone. Its sheer size suggests it could host moons as big as Earth, each one a potential haven. But Majra is just one candidate among many we've spotted in the vastness. Let's travel to another system, to a planet called HD 6005c, a 3.5 Jupiter mass giant orbiting 3.5 astronomical units from its star. This star is swelling into a red giant, its habitable zone shifting outward, placing HD 6005c in a fleeting sweet spot. Imagine a moon here, bathed in the dying star's crimson glow, its surface warm just enough to hold liquid water. The scene is haunting, a world on borrowed time, orbiting a planet that's a fraction of Majordidi's size, its moons likely smaller, perhaps Mars-sized at best. The odds of habitability here feel slim, like a candle flickering in a storm. Yet the idea of life persisting in the shadow of a dying star stirs something profound in us. Now shift your gaze to HD 221287b, or Pipeta, a mysterious giant orbiting a sun-like star. Pipeta's mass is uncertain, somewhere between 3 and 40 Jupiter masses, teetering on the edge of brown dwarf territory. It sits in its star's habitable zone, a cosmic stage where moons could thrive. What makes Pipeta extraordinary is the whisper of possibility from earlier studies. It might not only host Earth-like moons, but also Trojan planets, smaller worlds sharing its orbit at stable gravitational points. Imagine standing on a Pipeta moon, the gas giant filling half the sky, while a distant Trojan planet glimmers like a second Earth. The thought is dizzying, but the uncertainty of Pipeta's mass casts a shadow. If it's closer to 40 Jupiter masses, its radiation and tidal forces could scorch any moon's chances, turning potential havens into barren rocks. Yet if it's lighter, the balance might just tip toward life. Then there's 47 Ursae Majoris b, named Tapo Tong, a 2.5 Jupiter mass planet orbiting 2 astronomical units from its star, Chalawan. This system is a chaotic dance. Tapo Tong's presence destabilizes rocky planets in the habitable zone, but its moons could be warmed by tidal forces, even at this distance. Picture a moon here, its surface cracked by tidal stress, yet holding pools of water heated from within. The star's light is dimmer, but the planet's gravitational pull keeps the moon alive, a delicate balance of warmth and stability. Tapo Tong's moons, if they exist, would need to be just right. Not too close to be roasted, not too far to freeze. The universe seems to dangle these possibilities before us, each one a fragile thread of hope. These planets, Majordidi, HD 6005c, Pipeta, Tapotong, are our best bets, based on models of 10 Jupiter mass giants that suggest Earth-sized moons are not just possible, but likely in the habitable zone. At 1 astronomical unit from a sun-like star, these moons average 46% of Earth's mass, big enough to hold atmospheres and oceans. But move further out to 2 or 3 astronomical units, and the moons shrink, their sizes dropping to a third or less of Earth's. At 5 astronomical units, like Jupiter's orbit, the chances grow slimmer, the moon smaller, relying on tidal heating to stay warm. The study paints a clear picture. Closer to the star, you get fewer, larger moons. Further out, more, but smaller ones. The habitable zone is the sweet spot, but even there, most moons are either too hot, scorched by tidal forces, or too small to sustain life. At 2 astronomical units, tidal heating becomes the hero, warming moons to Earth-like temperatures. But the lack of starlight and intense gravitational tugs make habitability a long shot. The challenges these moons face are relentless. Radiation belts, like those around Jupiter, can strip atmospheres bare. Io, Jupiter's tortured moon, is a cautionary tale. Its volcanoes churn, but the planet's magnetic field rips away any hope of air. A habitable moon needs to orbit beyond this danger zone, yet close enough for tidal heating to work its magic. Then there's water. Without it, even the most perfectly placed moon is lifeless. An atmosphere, too, must be just right. Too thick, and you get a Venus-like greenhouse hell. Too thin, and it's a Martian wasteland. Tidal locking adds another twist, potentially freezing one side of the moon while baking the other. Every factor, size, orbit, water, atmosphere, must align like stars in a cosmic constellation. The odds feel overwhelming, yet the sheer number of stars in the Milky Way, each potentially hosting giants with moons, keeps the dream alive. What tugs at the heart is the fragility of it all. These moons, if they exist, are cosmic miracles, worlds that defy the odds to cradle life. The thought of standing on one, feeling alien soil underfoot, watching a gas giant rise like a second sun, fills us with awe. But it also humbles us. We found no confirmed exomoons yet, only candidates like those around Kepler-49b, faint signals in the data that tease what might be. The technology to spot these moons is just emerging, like a telescope slowly coming into focus. Each new discovery, each candidate planet, feels like a step closer to an answer. The universe is vast, and while habitable moons may be rare, they're not impossible. The study suggests they could even exist outside the habitable zone, warmed by tidal forces in the cold reaches of a system, a reminder that life might find a way in the most unexpected places. This journey isn't just about science. It's about the human spirit reaching for connection. Every planet we study, every moon we imagine, is a question we ask the cosmos. Are we alone? The answer might lie in the shadow of a gas giant, on a moon we can't yet see, but the search itself is a testament to our curiosity, our refusal to stop dreaming. In the final part, we'll confront the reality of these odds, explore what it would take for a moon to truly be habitable, and dare to imagine what finding one would mean for us all. For now, hold on to the image of a distant moon, its surface shimmering under a giant's glow, whispering possibilities we're only beginning to understand. The search for habitable moons feels like chasing a whisper across the cosmos, a faint, tantalizing hint of life on worlds we can barely imagine. We've journeyed through the possibilities, from the massive Madriditi to the enigmatic Pipetta and the distant Tapotong, each a potential cradle for Earth-like moons. These worlds, orbiting gas giants in the delicate embrace of a star's habitable zone, dangle the promise of life in front of us. But the universe is a harsh gatekeeper, and the path to a truly habitable moon is littered with obstacles that test the limits of hope. As we stand on the edge of discovery, let's confront the reality of these odds. Imagine what it would mean to find such a world, and let the weight of this cosmic quest settle into our hearts. Picture yourself on a moon orbiting Pipita, a gas giant that might be a planet or a brown dwarf, its mass a mystery that could make or break its moon's chances. The sky is dominated by Pipita's swirling storms, a mesmerizing chaos of color that feels alive. The ground beneath you is rocky, kissed by a thin atmosphere that carries the faint tang of minerals and water. A distant star, sun-like but alien, casts just enough light to keep oceans liquid. You're standing on a world that's not a planet but a moon, yet it feels like home. This is the dream, a place where life could thrive, where the air is breathable, where the view of a gas giant rising on the horizon stirs something ancient in your soul. But the reality is a gauntlet of cosmic forces, each one a hurdle that could snuff out that dream in an instant. The odds of a moon being habitable are razor thin. It needs to be big enough, think Mars or larger, to hold an atmosphere and sustain geological activity. It needs water, not just locked in ice, but flowing in rivers or pooling in seas. It needs an atmosphere that's neither too thick, trapping heat like Venus, nor too thin, leaving it barren like Mars. And it needs to orbit in a sweet spot, far enough from its planet to avoid being scorched by radiation or tidal heating, yet close enough to benefit from the warmth that could sustain life. Studies suggest that for a 10 Jupiter-mass planet like Madriditi, At 1 astronomical unit from a sun-like star, over half the moons are too hot, their surfaces boiled by tidal forces. Move to 2 astronomical units, and most are too cold, starved of starlight. At 3 astronomical units or beyond, only a rare few, warmed just right by tidal heating, have a shot at Earth-like conditions, and even then, they're often smaller than Mars, their chances dwindling with distance. The challenges don't end there. Radiation from a gas giant's magnetic field can strip a moon's atmosphere faster than it forms, as we see with Jupiter's Io, a volcanic inferno with no air to speak of. Tidal locking could plunge one side of the moon into eternal cold while roasting the other, creating climates too extreme for life as we know it. And then there's the question of formation. Moons need the right mix of materials, enough water, and a stable orbit to even have a chance. The study we've leaned on paints a picture of possibility, but also of rarity. At 1 astronomical unit, moons averaging half Earth's mass are common, but only those orbiting between 12 and 33% of the planet's Hill sphere, the region where its gravity dominates, hit the temperature sweet spot. Even then, everything else must align perfectly. Water, atmosphere, magnetic protection, and 1,000 other factors we're only beginning to understand. Yet the universe is vast, and rarity isn't impossibility. We've found planets like Majority, Pipera, and Tapotong that fit the profile, gas giants in or near habitable zones, massive enough to host large moons. None are confirmed to have moons, let alone habitable ones, but they're candidates, beacons in the dark. The study lists others too, like HD 6005c, orbiting a dying star, its moons facing a ticking clock as the star expands. Each candidate is a story of its own, a world where life might cling to existence against all odds. The thought of a moon around Tapotong, warmed by tidal forces at 2 astronomical units, or one orbiting Pipeta, sharing its system with Trojan planets, sparks a sense of wonder. These aren't just data points, they're possibilities that challenge our understanding of where life can take root. The search for exomoons is still in its infancy. We've spotted hints like the candidate around Kepler, 49b, but no confirmed exomoon has yet graced our telescopes. The technology is catching up, though, with new observatories and techniques sharpening our view. Each year brings us closer, and the moment we confirm the first exomoon, the floodgates will open. Imagine the day we detect a moon with Earth-like traits, oxygen in its atmosphere, water on its surface, perhaps even signs of life. It would be more than a discovery, it would be a turning point, a moment that redefines our place in the cosmos. We'd no longer be alone, not just in our system but in the universe, connected to a distant world that shares our spark. This quest is as much about us as it is about the stars. Every planet we study, every moon we imagine, is a mirror reflecting our own curiosity, our longing to find others out there. The idea of a habitable moon, a world orbiting a gas giant, its skies painted with alien hues, captures something primal. It's the same instinct that drove explorers across oceans, that sent us to the moon, that keeps us peering into the void. The odds may be steep, the challenge is immense, but the universe has a way of surprising us. Life might thrive in the unlikeliest places, on a moon warmed by a planet's pull, far from the star's light. The study suggests these moons are rare but possible, and that possibility is enough to keep us searching. As we close this chapter, let's hold on to the image of that moon, its surface alive with the promise of water and air, its parent planet a silent guardian in the sky. The universe doesn't hand us answers. It dares us to find them. Habitable moons might be out there, waiting, their stories unwritten until we turn our gaze their way. The search continues, not because it's easy, but because it's who we are. We're the species that looks to the stars and asks, what if? And somewhere, orbiting a distant giant, a moon might be waiting to answer.